Hi, this is Lakshmikant Tiwari. Today I am going to take you through a Numpy crash course. It will be around 1.5 hour long tutorial, and I'll be taking you through the basics of the Numpy, and then I'll be also taking you through a little bit advanced stages into a Numpy. Numpy and the pandas is a fundamental and the backbone of a machine learning programming techniques. I have already taught a pandas crash course. You can go ahead and watch my pandas crash course. Although in this tutorial series I'll be telling you Numpy. To install a Numpy, you need to first install Anaconda. If I'm sure you have Anaconda already on your computer already, it is installed. Then if it is already installed, then you do not need to install Numpy separately. It automatically comes installed into Anaconda distribution. So let's suppose that you have Anaconda and the Numpy installed on your computer. Then you need to open an Anaconda. So let's open Anaconda. Open Anaconda. I would suggest you to open Anaconda into administrator permission. Otherwise, sometimes what happens when you need to install some library, it might get stuck into an error since it doesn't get a permission to write into your C drive. So here we have administrator permission for Anaconda prompt. Let's change this directory to our working directory, and our working directory is here, Numpy complete crash course. So I'm going to just copy this and then I'm going to paste it here with the change directory cd. And once we have navigated our Anaconda prompt into our working directory, then we need to write here a Jupyter notebook. So write here Jupyter notebook. It will run a small server on your computer, and then locally it will open a web browser and with the local host. So here we have a web browser with a local host. Now we need to create a file here. Either you can upload a file that is already available on your computer, otherwise you can create a new file here. And let's change this name of this file. We are going to change it Numpy crash course. Okay, perfect. So we start our tutorial first importing a Numpy as a NP. Okay, so import Numpy as NP, right? So before we go ahead, I would like to tell you a few shortcuts of Jupyter notebook that will be very handy throughout our coding. Let's say you have a cell, and if you press a escape key, then it will come out of this cell, and then you need to press H in your keyboard. Then it will bring a keyboard shortcuts. In a keyboard shortcuts, you will get here the shortcuts which can be used while coding. It will ultimately increase your coding speed, such as, let's say you want to give a heading, so you need to first change your cell into the markdown, and after that you need to change your cell into heading 1. Now once you have this one, then you can insert cell above, cell below, and you can cut the cell, and you can copy a cell, you can paste a cell below, or you can paste a cell above, or you can undo a cell deletion, etc. Okay, perfect. Now what are the other things which we can do actually? So since we have imported our Numpy, and we can run this cell in a 3-way. Either we can press Control and the Enter, Shift and Enter, Alt and Enter. Let's say what happens when we press Control and Enter. So if we press Control and Enter, it will just import this Numpy as NP, but it will not insert another cell. But if we press here Shift and Enter, it will execute this cell, and it will advance into the next cell. And if next cell is not available, it will automatically insert a new cell, right? And if we press here again, let's come back to the cell number 1, which is 2 here. If we press here shift and enter, now you see new cell is not being inserted. Let's say again come back to the cell number 1, and if we press here alt and enter, you will see here a new cell has been introduced. Okay, so let's say let's execute this cell. There is nothing here. Let's say just print here 1. You will see here the 5. Now let's again execute first cell with the alt and enter. Now you will see here a new cell has been introduced in between 5 and 6. Right, so this is the way how we can do keyboard shortcuts in Jupyter Notebook. And let's again press escape and let's cut all these cells. We can utilize X on your keyboard, so I'm pressing here X. It has just deleted all other cell. Let's again press shift and the enter. It will insert a new cell and it will execute the current cell. Alright, so let's come back to the Numpy. What is the Numpy? Numpy is the most basic and the powerful package for a scientific computing and data manipulation into the Python. We will be taking through in this tutorial series how to create a Numpy, how to inspect the size and the shape of a Numpy array, how to extract a specific item from an array, how to reverse rows and the whole array, how to represent missing value and infinite, how to compute mean, max or other statistical parameters on a Numpy array, how to create a new array from an existing array, reshapings and flattening, rivals and so many other things we can do with the Numpy. So we will be taking all those techniques in this tutorial. Right, so let's start a Numpy by creating a 1D array first. We have already imported a Numpy as NP. So let's first create a list 1. Okay, so here we have a list here. Let's say the 0, 1, 2, 3, 4. Okay, let's execute this and you see here we have a list 1. So the list 1 is 0, 1, 2, 3 and 4. So this is list, right? But this is not a Numpy array. And let's create another Numpy array that we are going to say that the array 1D. Okay, so that we can do as np array, and then we can say that here and array 1D. So now here we have two output at out 10 and out 12. At out 10 you see this is the list and here it is the array. Now one question can come in your mind, what is the difference between list and a Numpy array? Right? The key difference between an array and a list is array are designed to handle vectorized operation while a Python list is not. Once a Numpy array is defined with a particular size, its size cannot be increased. Although the list size can be increased. Let's say we have here list 1 of size 5. Okay, we can insert a new item into this list. We need to just append. Okay, list 1 dot append. Let's append 5 here and we can see here list 1 a 5 has been appended. But in array 1D that its size is already defined by np array. So this much of the memory has been already allocated for this array 1D. A new size cannot be increased for this array 1D. If you want to increase the size of this array, then you need to create another new array. Right? What is the another difference between this list and the array? Let's say if you want to add something, a sum number in whole array or a whole list, then it's pretty simple into a Numpy array, but it is not simple into a list. For example, let's say if I do list 1 plus 2, okay, I'll get an error. But if I do array 1D and plus 2, I will not get the error. So what happens here? 2 has been added into all elements of the array 1. Okay, so here you see array 1D, the first element was 0. Now it is added here the 2, it becomes the 2, 3, 4, 5 and the 6. But in the list 2, it is not. That means what we can say that here, once numpy array is created, you cannot increase its size, and you cannot once a list is created, then you cannot add you cannot do element wise operation like into a numpy array. Okay, right, perfect. So nevertheless, there are so many more advantages of a numpy array. So we'll be taking those, we'll be learning about those advantages throughout this tutorial series, right? So let's say if you want to create a 2D array. So far we have talked about 1D array, right? Let's say if I ask you to create a 2-dimensional array, then how you can create that? Let's first insert few rows here, so that we can work here smartly. Perfect. Now let's say we have here list 2. The list 2 is equal to, here we have a list 2. Earlier we had a list 1 that was just a single list, but we need to create here a list of list. So if we create a list of list, then list of list will automatically converted into a 2D array, into a numpy array, 2D numpy array. So let's say here we have 1 and 1, right? And here another list we have 2 and 2, and here we have another list, let's say 3 and 3. Okay, so this is a list 2, a list of a list. Let's create a 2-dimensional of array, an numpy array. So here we can say the np array, np.array, then we are going to pass here list 2, and if we see here array 2D, now you see its sizes. It's a 3 by 3 matrix, which we can say that it is a 2 by 2 matrix, right? Perfect. But what is the data type? What is the data type? So you can get the type here. You can get a type here. So the type is here ND array, but let's say if you want element type here, then you can say here the D type, the data type here in 32. Alright, at the same time, at the loading time, let's say if you want to add it in, you want to convert it into the float, then that can be also done. How you can do that? You can do here the array 2D, the np dot array, then you need to pass here list 2, and then we can give here the data types for which we want to create this array, right? So the D type is equal to, let's say here we have a float. Now array 2D, if we print array 2D, now it is a float, 1 point. So 1 point represents it is a float, right? And apart from that, one more thing I would like to tell you, that if you place your cursor in between this parenthesis, round parenthesis, and press shift and tab, you will get here some suggestion, right? That is the documentation of any methods into a Python, right? So this says that it takes the first input as an object, and then it takes second input as the data type. So if data type by default is none, then it automatically converts the same data type as the object data type, right? Perfect. If you want to understand more about the copy, order, and sub OK, ND, minimum, etc., then you need to press shift and double tab. So once you press shift and double tab, then you can get a complete documentation of np.array, and then you can come here and you can see here, if copy is true, then the object is copied, otherwise a copy will be made. Okay, and here order is optional, it is specify the memory layout of the array. If object is not an array, the newly created array will be into a C order, okay, unless F is specified. So in this, in which case it will be a 4-turn order, that is the column measure. So these are the detailed documentation which you can with this help of the documentation you can learn more about any Python methods. Right, perfect. Now let's go ahead and let's create a let's change the array. Okay, so let's say now we have this array. Let's change the data type of the array. Now we have array type is a float. Now I am trying to change it into the integer. How we can do that? We can do that, of course, array 2D, that array 2D, and then we can say the age type. Age type, that's mean we are going to change it, and we are going to change it into the integer. Okay, now it is into an integer. Okay, you see here now it has been changed into integer. Now let's say if I tell you to change it into a string, then how would you change it? Array 2D dot age type, and then I would say it str. Okay, now it has become into the string. You see here this is 1.0. Why this is 1.0? Because still array 2D is a floating type. Here I had just changed it into an integer, but I had not assigned this new data type change into another variable or in itself its variable. Okay, if I say here array 2D is equal to array 2D as type int, and if I then execute this one, now in this execution array 2D was changed from float to int, and then this int was changed into str. That's why it has become 1 1 1 and 2 and 3. Right, perfect. Right, there is another difference. There is one more difference between Numpy array and the list. Let's say here once again we have list 2 here, list 1, let's say for example. So the data type of the list 1, I don't think we get the data type into the list object. So here into the list 1 we have all the objects of an integer, but we can also append here another data type. Let's say we want to insert here 6, that is the string. Right, so let's say if we print here list 1, now we will get here 0 to 5, it is integer, but the 6th item is a string here. So this is another major difference between Numpy array and a list. So list can be the collection or a combination of many data types, but a Numpy array can be only a single data types. Okay, either it could be integer, string, or float, or any other kind of the object, but that the object should be, all the items into a Numpy array should be of a same data type. Perfect. Now we have seen how we can convert a list into a Numpy array. So of course then there has to be a similar techniques to convert Numpy array into a list, and of course we can do that in the same way. Let's say once again we assign here list to underscore here, let's say np to list, and then what we can do here, we can assign here our Numpy array which we want to change here. So the Numpy array we are going to change into a list, and that Numpy array is array 2D, and then we can say here the to list. Perfect. And then here you see here np list has been again changed back to the list. Okay, and similarly there are so many other things are available to do on Numpy array. It could be either 1D array or the 2D array. We can do also a string here. If we see here, so this has become a string, and if you remember this, so this is not a typical string, but it is a ASCII string. Okay, so byte string, you can say this is the byte string. And similarly you can see here the array 2D, that's the 2 bytes. If you see here, this two string and the 2 bytes are representing the same things. This will be very helpful when we will be doing some the communication protocols, communication data transfers, like uploading some data to the server or receiving data from the server. So mostly the data receptions or transmissions are being done into the chunks of the byte. Okay, perfect. So this is all about this module. In this module, we have learned what is the difference between the Numpy array and the list. And once array is created, we cannot increase its size. But in the Numpy array, we can do element-wise operation, but in the list, we cannot do. And Numpy array can hold a similar type of the data types, but in the list, we can add the multiple data types together, like integer, float, and the string. And we can convert a list into a Numpy array, and similarly, we can convert a Numpy array into a list. Now let's take how we can inspect a size and a shape of a Numpy array. Okay. So we have a list too. Okay. Now what I'm going to do here, I'm going to press M on my keyboard. Now you see here, it has been changed to the markdown, and then I'm going to press 1 in my keyboard. Now it has become heading 1. Then I'm going to type here D type, okay, and save. Okay, now we have a D type and the save. So let's say what is the list 2. List 2 is still a list, 2-dimensional list. Okay, now we want to convert this list 2 into array. That's the floating point array. So here we have array 2D. Okay, so here we have array 2D. I think we already have array 2D. Do we have? We need to convert back it into the code by pressing Y. Yes, we have array already into the int, but let's convert this array into as with the as type, and we are going to pass here float. And if we press here shift and the tab, we will see here it says that the data type, the order, casting, that is the unsafe, sub, okay, and etc. You can press shift and double tap, then you can get a detailed documentation about the as type. Okay, so I'm going to save this into the array 2D. Right, now we have array 2D here. So the array 2D is now currently assigned into a float. Perfect. Now I am going to utilize the the Python method, that is the print. So if we type here the print, this print are used into Python 3, and the print without parentheses can be used into Python 2, but we are using here Python 3. That means we will be using print with the parentheses. Okay, so here we have a shape, and then we can do we can write here array 2D dot shape. Okay, so the shape is 3 by 3 here. Okay, and similarly we can get a data type of array 2D that we can get with the D type, that is the float 64. Okay, and similarly we can get a size of this array with the size. Okay, here we have a size that is the 9. You can see here there is a 9 element, that means its size is 9. And we can also get a dimension of the matrix. I mean, it is the 2D or the 3-dimensional matrix. Definitely we can get that. But before that, let's take the the size of 1D array. Its size is 5, and let's get the dimension that we can get with the ndim array 2D, and then we can get with the ndim, that is the 2. And similarly, if we type here add1 dot ndim, that is the 1. Okay, perfect. So here we have a 2-dimensional array and the 1-dimensional array. Perfect. Right. how to extract that specific item from the array. Now the question is that, let's say we have here array 1D. If I ask you how to extract each number, okay, I would like to first square this array. Okay, so the array 1D, and if I do like this, you will see here array 1D now has been this is the operation. Oh, I think we need to square it, that we can do array 1D. Okay, perfect. Sorry. Okay, so this has become a square overall, right? Now let's see if we want to extract some specific item, how we can do. Definitely we can do by indexing. Let's say we have array 1D with the 0. Sorry. Oh, with the 0 we can get item at the 0th index, and with the 1 we can get item at the first index. But the question arises, what will happen if the list is the two-dimensional? For example, let's say if we have array 2D. Okay, so if we type array 2D the 0, then what will come here? You see here the first row. That means this is the row and then column. Okay, then this is the column. Then how it works? It works like this. This is the row and this is the column. Okay, so here I have I have written here 0 0. That means it will get this item 0th row and the 0th column, that is the 1. If I write here 0 and the 1, that means the 0th row and this first column. If I write here the 1 and the 0, that means 1 and the 0, that means the first row and the 0th column, that is this one. Okay, so let's write here 1 and the 0, then we should get the 2, and we have got the 2 here. Okay, so this is how we can get any specific number, okay, from any index. So let's say if you want to select some numbers with some condition, okay, what I'm trying to say here, Numpy array support a Boolean indexing. That means a Boolean index array is of the same shape as an array to be filtered. For example, let's say if I say here bool array, okay, and I want all the elements which is less than 3, let's say. Okay, so I need to write here the array 2D and less than 3. Okay, then if we print here bool AR, then we will see here the true, and these are the false. Because this condition was met into only array row 1 and the row 2. This condition was not met for row number 3. That means it will only print this row. So for this, what I can do, I can write here array 2D, and then I can write here bool AR. Okay, so now we have got here, now I have got here the array that is just 1 1 1 2 2 2 2. Okay, that means I have got all the number which are less than 3. Okay, so this is the way how we can proceed. Perfect. Now let's go ahead and understand how we can reverse the rows and the whole array. For example, let's say we have array 2D. Okay, here we have array 2D 1 1 1 2 2 2 and 3 3 3. Okay, so let's say if we want to reverse this array, then how we can do that? This is the very simple. Let's say we can write here the array 2D, sorry, with the full column. Okay, and then -1, it will just reverse the rows. That means what it will do, it will bring the last row to the first row and the first row to the last row. Okay, now let's say if we want to change rows and the column together, then how we can do? Okay, it is kind of the transposing, what I am going to say. Okay, what I am going to do. Okay, array 2D, and if you press here shift and double tap, then you will get here the lots of the documentation which you can perform here, right? So the array 2D, then I'm going to provide here the double full colon, and then the -1, that's mean the rows are going to be interchanged reverse order, and then double colon and then -1, right? So you see here the rows and the column has been changed here, although it will not be visible here, rows and the column. Okay, and so this is the way how we can change our rows and the column. Okay, perfect. Now let's go ahead and see how we can change, how we can represent not number and infinity values into our Numpy arrays. Okay, so I'm going to change this into the markdown, and then I'm going to write here the heading with second. I'm going to do here np.nan and np.inf. Okay, perfect. So if I say here np.nan, so that is the not number, and similarly if I say here np.inf, that is the infinite. Okay, so these two type of the number cannot be these two type of the number actually provides some intuition behind the data. That's mean if any data is NaN or INF, that's mean statistical operation cannot be done on those data, since we do not have a missing numbers. So there are some techniques we can fill those missing numbers. I'll be taking that ahead in this tutorial, but let's first discuss what is the NaN and what is the INF. NaN means not a number. Let's say if any number that cannot be represented into integer, float, or numeric number, that is the NaN, or any number which is infinite, that is the np.inf. Okay, so let's say we have here our array 2D. Okay, and here we have array 2D 1 1 2 2 and 3 3 3, and let's insert few more rows here into our notebook. Now one more thing I'm going to tell you, how you can insert any number, or how you can manipulate any number into Numpy array, right? So let's insert NA into first location, and at the second location let's insert INF, that is the infinite number. Okay, so here I'm going to do here ARR2D 0, that's the 0th row and the 0th column, and then np.nan, and similarly I'm going to do here the array 2D and then 0 1 np.inf and then array 2D, right? You see here now we have NaN and INF, right? That means, let's say if I ask you to calculate the mean of this row, can you do? I don't think you can do, since there is infinite, but you can definitely calculate the mean of this row and the mean of this row. And similarly, if I ask you to calculate the mean of this column, you cannot do, and similarly for this column you can't do, but for this column definitely you can do. Okay, perfect. Right, now let's say, so this is the very small array, and by printing this array we can get and we can understand there is infinite number or not a number present into the array. Let's say if you have a very big array, like into a data science projects or data mining projects, how would you ensure that your array do not have any null value or not a number or infinite value? So there are some ways or some method into a Numpy to check if this Numpy array contains any not a number or any infinite number. Then definitely we can do that with the np.isNaN. Okay, and array 2D, if we print this, it will check and see if any of the element is not a number. So we see here the first element is not a number, but other elements are a number, although the second element is the infinite, but yes, that is some kind of the number. And similarly, we can check if any number is a infinite. So NP is INF, there is. Okay, and then we can pass here ARR and then 2D. So this says that there is just a single number which is infinite, that is this one. Okay, and in this way we can get if there is any number that is a infinite number. Okay, and similarly, let's say if you want to replace or you want to get any number which is infinite, then how would you do that? Then let's say I'll create a flag here. Okay, missing flag. Then the missing flag will be like this: np dot isGenAI and then array 2D, and then we would have OR operation here, and similarly np is INF, and then we will have here array 2D, and if we print this missing flag, we will see here that these are the two numbers which are either NaN or INF. Now let's say our goal is replace it with the 0. Okay, replace INF and NaN with 0. How we can do that? Definitely, it's really very simple. We need to provide this, but before that, one thing I would like to get here: those numbers which are infinite are NaN. So similarly, as we were doing here, okay, with the boolean, with some kind of the boolean operation, the similar things we can do here: array 2D and then the missing flag, right? So we will get these are the numbers which are NaN and the INF. Now we need to change these numbers. So definitely we can do copy it and paste it here, and let's place it to 0. Okay, perfect. Now let's print array 2D. Now we will get here these NaN and INF number has been replaced with the 0, and the other numbers are the similar numbers. Okay, so this is the way how we do how we introduce NaN or INF, and how we can handle not a number or INF value into your Numpy array. Now let's go ahead and compute statistical measures, or let's do some statistical operations on your Numpy array here. Okay, so in it statistical operation, what I'm going to do here, first of all, that I'm going to create here mean, standard deviation, variance, and kurtosis. There are so many things which we can do actually, right? There are so many things. I'll show you how we can do. So we can do here the array 2D, then we can type here mean, the mean of the array 2D, that's mean all the elements here. Okay, sum all these elements, and then we can divide by 9, we will get the mean is 1.77. okay, and similarly we can get the max value present in this array, that is the 3, and similarly we can get mean value present into this array, that is the 0, and similarly we can get the variance or the STD of this array, that is the 1.13, and similarly we can get array 2D dot variance. Okay, and similarly we can do here, if we press here dot and press the tab, there are so many things which we can do on this array, right? Like max, mean, and Dimension etc. we can of course get here, but there are so many other things which we can get, like a sorting. So that will sort, squeeze, and sum etc. So let's squeeze it first, then sorry. So if we squeeze it, we will get it here something like this, although there is not much difference here while doing squeeze. And if we press here shift and the tab, we can understand what is the squeeze. So squeeze, what it do single dimensional entries from the shape of A. Okay, perfect, right? And this is about the squeeze, mean, max etc. we have already calculated. Now let's get a cumulative sum. Okay, what is the cumulative sum? Computing the sum of the number by number is the cumulative sum. So here we will get the array2d dot cum sum, that is the cumulative sum. That is the 0, and then the 1 0 0, that is the 1, and then 2 and previous value is the 3, and then this is the 3, and then 2 and this previous value is 5, and then 2 and the 5 is 7, and then 3 and this one. This is the overall cumulative sum. Okay, perfect. Now let's see how we can create an array from an existing array. So we already have array, the 2D array into the array 2D, and let's say how we can create an array of 2 by 2 array. Okay, so we can do here with AR, that is the array, and that the array 2D. Then we can take here the all the rows. Okay, all the rows, but only till the to the row. Okay, and all the column, all column till the second column. Okay, and then here we have ARR. That's mean we have selected this and this, right? Okay, that's mean here we have seconded the 2 row from the initial, and here the 2 row. Okay, and similarly what we can do, let's press B in your keyboard, insert few more rows. Let's say if I say array 2D and 1 and 3, okay, and similarly if we say here 1 and 3, right, we get here the 2 2 and 3 3, right? That's mean we get this one. Okay, that's mean we have got here 1 and the 2 number. Okay, that's mean 1 and the second here, right? Let's say if I write here 1 and the 2, that's mean I'll get just a single column, that's mean this column. Okay, the 2 and the 3 column. Okay, 2 and the 3. Perfect. Now let's say how we can do the reshaping. Okay, how we can do a reshape. Let's say we have our array 2D, which is 3 by 3 matrix. Now let's say I want to make it something like let's reshape it in some other form. Okay, and let's see what happens. Array 2D here. Okay, here we have array 2D and then reshape. Now we are going to reshape this array into 3 cross 4. There would be error. Why? Because this array size is just 9, but we are trying to reshape it into a 12 size. That means it will be not done. But if I do here 1 cross 9, then it will be definitely done, right? That means it has become now the single row, okay, and the 9 column. And similarly, if I say here array 2D and then the reshape, okay, a 9 cross 1, then it will become here a single column and 9 rows. Okay, so this is how we reshape a NumPy array. Perfect. Now let's say we have our array, and let's try to understand how we can this flatten this array. Okay, so this is although we have reshaped it, but we need to understand. Let's say we have a big array but we don't know the size of the array, right? Then how would you do the reshaping? That's mean beforehand we need to understand, or we need to know the size of an array or the shape of the array. Suppose that we don't have an array, then how would you do that? You can do with the flatten. Let's say you have array 2D, then we can use a flatten here. Okay, so with the flatten, what we have done here, this the two-dimensional array or a list of list has been converted into a single dimensional array. See here, this is the flatten. Although we have reshaped it, but you see here, this is still a two-dimensional array. Okay, if you see here, ndim, I don't think it can be applied there. Let's say if we take it here into A, and if we say here A and dim, then we get still a dimension of A is a 2, and the A is still, you can see here it is a single row, but the dimension is the 2. But if we do a flatten, then it will automatically convert this multi-dimensional array into a single dimensional array. Okay, but there is another thing also here, array 2D dot rival. Okay, so in rival also we have got a single dimensional array. Now the question arises, what is the difference between flatten and rival? The difference between rival and flatten is the way array created using rival is actually a reference to a parent array. Okay, so any changes to a new array will affect the parent as well, but it is memory efficient. Okay, that means let's say you are doing a data mining and your single array size is very large. If you assign this flatten array, okay, into A, okay, let's do like this, then it creates a copy of this flatten array into A. Okay, but if I do like this, B is equal to the array 2D dot B, okay, is equal to like this, then what happens here? It is just created a reference, but here it is the copy. I'll show you what is the difference. This is the copy, but here this is the reference. That means if it is a reference, if I change anything here, it will automatically change here array 2D. For example, let's say here we have array 2D, a similar. Now let's change this 0. Okay, I'm going to change that 0 here into the B. In B, we can access that B0 with -1. Okay, now let's run this array 2D. AR2D. Now see here, this is the what I was talking about, right? So this happens because I had created a reference with the rival, right? Since rival do not allocate new memory, that means it is a memory efficient. It is a very much memory efficient. Okay, so this is the major difference between rival and the flatten. Okay, now let's see how we can create a sequence, repetition and the random number using a Numpy. Okay, here I'm going to create a sequence and repetitions and random numbers, okay, using Numpy. How we can do that? Let's say if we do here numpy dot arrange, okay, numpy dot arrange. In parentheses, you need to shift here, you need to press here shift and the tab. You will see here in arrange what it says, that there is a start, there is a stop, and then there is a data type. Okay, and it says that values are generated within the half open intervals. That's mean it will take a start, but it will not take a stop. Okay, in other words, the interval includes start, but it will exclude the stop. Okay, for example, let's say if I say here 1 and 5, it will generate a number in between 1 and 5. That's mean it will include 1, but it will not include 5. Okay, it has just generated a number from 1, 2, 3 and the 4. And if you again press here shift and the tab, you will see here there is data type. Data, how what type of the number we want to generate. Okay, so let's say if we say here the d type float, then it will generate a float number. If I say here the int, it will generate an int. If I say here str, it will I don't think it has str. Does object, does it have object? Yes, it has an object. Okay, so this is the data type. Okay, we can see and understand what type of the data types we want. Now one more thing you might have noticed here, if we press again shift and the tab, you see here there is the start, there is a stop and there is a step. Okay, that means we have a number generated in between 1 and the 5, and the difference between those consecutive number is 1. That is the default. Let's say if we want to generate all the sum numbers in between even numbers, all the even numbers in between 1 to 50. Okay, then how we can do that? np dot arrange the 2 and 50 and of course the 2. Okay, so all the even numbers will be generated here. See here. Okay, let's say if we want to generate all the odd numbers, then definitely we can do like this. Okay, so all the odd numbers were generated here. Okay, so this one shows this one represents the step, that's mean the difference between two consecutive numbers into a numpy array. Okay, perfect. So this is the one way to generate a numpy array in the form of the list. Okay, and there are other methods which we can do, like a line space. Okay, that means what is the let me write and then I'll explain you what is the difference here. Line space, we have a line space and 1 and the 50, and here we have a 2. Okay, you see what is the difference here? Line space says that how many exactly number do you want. Okay, if we press here shift and the tab, you will see here this says that the number, okay, how many numbers do you want, okay, to be printed in between 1 and the 50. Let's say if I write here a 50, then there will be a 50 number. If I write here 100, then there will be 100 numbers printed in between 1 and 50. So this is the difference between line space. In a line space, you can define here exact number of elements which you want to generate. That is the difference here. Okay, perfect. Okay, so that is the np.line space. And line space is a number which is generated linearly. But let's say if you want to generate a number into a log scale, then how would you do that? You can do that np.log space. Okay, that is the linear space, and here we have a log space. 1 and the 50. Let's say we want to generate the 10 number. In a log space, you might know that we get here total 10 numbers. Okay, here if you see here in log space, it returns number spaced evenly on a log space. Okay, so this says that it will return a 10 number, start will be 1 and stop will be the 50. Okay, that is the 10 power 50. Okay, in a log space, right? Perfect. And This is how we can generate a sequence with the arrange line space, linear space or log space. Similarly, we can do with the np.zeros. Okay, so let's say we want 2 cross 2, then let's say we want 2 cross 2. Here we have zeros of 2 cross 2, and similarly, let's say if we want to generate ones of 2 cross 2, then we will get here ones of 2 cross 2. Okay, perfect. Now let's say we have an array. Let's first add few more rows here. Let's say we have array A. Okay, so the array A is here 1, 2 and 3. Right, now let's say I want to repeat this array 3 times. Okay, 1 2 3, 1 2 3 and 1 2 3. How would you do that? That is the very simple, that is the np.tile. Okay, that's the repetition, np.tile, and then we need to give here A and 3. It will repeat this array 3 times, 1 2 3, 1 2 3 and 1 2 3. Okay, and similarly we can do with the repeat elements, but that will be a little different. For example, let's say if we do np.repeat, np.repeat method, and let's say we want to do a repeat into the A and we want to do a 3 times, then what it will do, it will repeat first element 3 times and then second element 3 times and then third element 3 times. And similarly we can do np.repeat. Okay, three. Okay, so you see here the array 2D has been repeated for a 3 time here. Okay, perfect. Right, so array 2D has been repeated 3 times here. The numbers has been increased by 3 times, so there are total 27 here. Okay, we can get with the size here. I don't think it will give a size here since it returns a number. Okay, right, now the question comes how we can generate a random numbers. So this is the random generation. This is number generation with arrange, linear space, log space, zeros, ones, tiles, repeat, etc. Now let's talk about the random number generator. How we can do that? That's very simple. We need to do here np.random.rand. Okay, and then we need to press here shift and the tab to understand it into the more detail. So this defines the dimension for how many dimension we want. If we pass here just a single number, it will print just a single array, a single number, random number. If we pass here multiple numbers, it will generate a multiple dimensional numbers. Okay, so let's say if we press if we pass here 1 cross 3, it will generate here 1 cross 3 array, that is the 2D. Okay, if I pass here 3 cross 3, it will generate here 3 cross 3 matrix. Okay, all these random numbers. Okay, if I keep pressing here, it will keep doing this one. Okay, perfect. Now let's go ahead and so this is the random random. For more detail, what we can do, this random number is uniformly distributed, and there is the random which is normally distributed. Okay, so that is the np dot random dot randn. Okay, so that is the normally distributed. Okay, so let's say if we press here 3 and 3, you see here, so this is the normally distributed and this is uniformly distributed. Okay, and one more thing, let's see, all the random numbers which is generated is in between -1 or kind of -1 or nearby -1, or you can say it is into the float. Okay, uniformly distributed, I think this is uniformly distributed in between 0 and 1. Okay, you see here it will tell you the return number that is in between 0 and 1. Okay, and this one return a number. Okay, uniformly distributed numbers, in fact. So the most of the number will be kind of okay, distributed around 0 or 1 and the -1. Okay, so this is the normally distributed random number. Here let's generate a random number with the integer. Okay, np dot random dot randint. Okay, so here 0 and the 10. Now we are going to generate a random number in between 0 and the 10, and you see here that is the 3. And similarly we can pass here a size. Here you see here low, high, and the size, and size we are going to pass here 3 cross 3. Okay, so there would be 3 cross 3 random number, and all the numbers will be in between 0 and 10. Okay, perfect. Right, so this is how we can do generate a random number. But let's say for some reason you want to reproduce your same random number, then how would you do that? You can do that with the random seed. Okay, the random seed, so that can be done with the np dot random dot seed. Okay, so let's say I'm passing here seed 0, and then I am going to pass this one. You see here, if I run this array multiple, if I run this cell multiple times, it will generate the same number. Since I have said here a seed, that is the 0. If I set it 1, then it will change it. Okay, now you see it has been changed. If I again pass it here 0, it will again change it. Okay, random seed 1. Okay, perfect. So this is about how we can generate random numbers into a Numpy. And now let's finally see how we can get a unique items and the counts, right? How we can get a unique items and the counts into a Numpy. Then that can be done with np dot let's say for example, let's say we have array 2D. Okay, I mean, I'm trying to say you that let's say you have a very large array and you want to calculate that how many items are unique and what is their counts. Then how would you do that? So that is the array 2D, and then you can pass here unique. Okay, then I think we should do with the np dot unique. Otherwise, let me see. No, that's the np dot unique. Okay, so these are the unique number: -1, 0, 1, 2, and the 3. You see here array 2D. In array 2D, these are the unique numbers. So the np dot unique array 2D represents returns a unique numbers. Okay, and similarly, let's say if you want to count as well, then how would you do that? Okay, so for that, what we can do like this. We can say here uniques, and then counts is equal to np dot unique. Okay, then we have here array 2D, and it says return counts, and that is I'm going to place a true. Okay, and now I'm going to print here Unix, and as well I'm going to print here counts. It says that -1 has been occurred just one time, and 0 was occurred one time, and +1 was occurred one time, but 2 was occurred 3 times, and the 3 was occurred 3 times. Okay, so this is how we can do which unique number how many time occurred into your NumPy array. Okay, so this is all about in this module. It has been almost an hour-long module. In the next video, I'll be also taking you through more knowledge of NumPy array, and also we'll be going a little bit into a deep knowledge or a deep state of NumPy. So thank you so much for watching this video. Please do not forget to subscribe this channel, and stay tuned with this video series. I'll be posting another video tutorial very soon. Bye bye. Have a nice day.